Alright, so we're going to start one of the most important things that you're going to learn in here, and that you'll use a lot in calculus. And so this is a really, really, really important lesson about the unit circle. And so the unit circle we use to evaluate problems like we have right here. Okay, and so right now you don't know how to do that right off the top of your head, but using the unit circle you'll be able to. So like I said, these problems come up in calculus. And so rather than just slapping a unit circle at you and making you memorize it, I want to show you where the unit circle comes from. And so you can build a unit circle, and I'm going to attach an activity. You can do this at the same time. And so it's the paper that has the circle, and at the bottom it's got the two triangles. And so you'll need to cut those triangles out. Don't cut the circle out, just cut the triangles out. And so before we do anything with special right triangles, I just want to take the unit circle. So you've got your blank circle that looks like this on your paper, and let's just label the easy points that we can pretty easily figure out what the coordinates and the radians are that we've talked about before. So if I start at the positive x-axis right here, that's where I'm always going to start. Anytime we are talking about the unit circle, we've said that the unit circle has a radius of 1. And so this little horizontal line right there that comes from the center of the circle to the edge of the circle is a radius. And so that distance is 1. So I can find what this coordinate out here is going to be. And so I'm looking at this point right here, and I want to know how far I have to go over to get to that. And since it's the same distance as the radius, it would just be 1. And then I go up, nothing. So it would be 1, 0 there. Now, I know that this is 0 degrees and 0 radians, and so I'm going to fill that in. Now, the next really easy coordinate that we can find would be right up here at 90 degrees. So we know that this is 90 degrees, and if you still don't know what that radian is, you can take 90 degrees and convert it to a radian using what we learned in the last lesson. So if we convert that, this is going to be pi over 2. And so if I want to know my unit or my coordinate right up here, I would go over 0 and then up 1, since that's a radius. Now I'm going to go out to here. That's an ugly line. I'm going to go out to that point that's at 180 degrees. So out here, it's really not much better, but this one is going to be at 180 degrees, which is also at pi. And so the point is going to be, I go over to the left this time, so instead of it being positive 1, it's going to be negative 1, 0. And then down here, I know that my degree is 270, and this is going to also be 3 pi over 2 as a radian. And if I find that coordinate, I would go over 0 and down negative 1. And then if we go all the way back around, this is going to end up being 360 degrees or 2 pi. Now, I can find those pretty easily just based on what we already know, but it's going to be harder for me to find these other angles on the circle, and that's where the special right triangles come into play. So this is where you need to have your triangles cut out. If you don't, go ahead and pause it, and then I'm going to just show you how we're going to label these special right triangles and how they're going to fit into our circle, and we're going to use them to build the unit circle. So the goal when we fill out unit circle is to find all the angles in radians and degrees and to find all the coordinates at each of those little points that we saw. And we're going to do that using 30, 60, 90 triangles and 45, 45, 90 triangles. And so you should have learned these rules about these special right triangles in geometry, and hopefully this is just a reminder of what they are. These triangles that we're going to use, and I'm just going to take one and copy it over. So let's copy that. These triangles are going to, I should have grouped that first. So let me group this so I can take it with me. So I'm going to copy this and paste it. I'm going to show you how it'll fit into your unit circle, and we're going to use it to build it. So these triangles are going to fit into your unit circle like that. And so we're going to use them to fill in all of these little points. And so this was a 30, 60, 90 degree triangle. And so we're going to go fill out this 30, 60 degree, 90 triangle. So this is a 30 degree, this is a 60 degree, that's your 90. And so the hypotenuse, since our triangle fits into the unit circle like this, the hypotenuse lines up with a radius on the unit circle. And so the radius of the unit circle is 1, and so the hypotenuse of our 30, 60, 90 triangle is also 1. Now, your short leg, which is across from the 30-degree angle, this is your short leg. The rule is it's the hypotenuse divided by 2. So the hypotenuse is 1, so 1 divided by 2 would mean the short leg is 1/2. Now, the long leg, the rule for that is just the short leg times the square root of 3. So I would say 1/2 times the square root of 3. This is like over 1. And so when I simplify this, 1 times the square root of 3 is the square root of 3, and 2 times 1 is 2. So the long leg should be square root of 3 over 2. Now, let's go ahead and fill in our 45, 45. So both of these angles are 45. The hypotenuse, again, is going to line up with a radius on the unit circle, and I'll show you that with that triangle in a second. So the hypotenuse is 1, and then the leg of that triangle is always going to be the hypotenuse times the square root of 2 all over 2. So this is just going to end up simplifying to square root of 2 over 2. And so that's what the two legs, since this is an isosceles triangle, 45s are the same, the legs are going to be the same. So this is square root of 2 over 2, square root of 2 over 2. So you need to label your 30, 60, 90 and 45, 45, 90 like I have them labeled. And then you also need to turn them over and label them on the other side as well, because you're going to be using that triangle to flip and manipulate on the unit circle. So all I did was I'm going to be using each one of these triangles, and I'm going to go ahead and group each of them so all of my writing goes with it. But and I didn't label my angles, but I will when we get to the unit circle. I'm going to go ahead and group these because I'm going to be using these triangles to fill in our unit circle. And so you should have your 30, 60, 90 triangle labeled. And so I've got it labeled over here. So I'm going to go ahead and show you how you're going to use that to build your triangle or your circle. So this is my 30 degree, this is my 60 degree. Now, that means that this angle right here is 30 degrees. And we also want that in a radian. So if you convert that, this is going to be pi over 6. Now, the other thing that I want is this coordinate that's there. And so we can find that coordinate by using the legs that we just found of this triangle. So I can get to this point right here by going this distance, square root of 3 over 2, on the x-axis, and then up the distance 1/2. So the coordinate of that point is square root of 3 over 2, comma 1/2. Now, I can use this triangle, and the way that you're going to do that is you're going to take this triangle. We can use it to fill in the angle on the other side of the second quadrant right over here. So the way that you would do that is by taking your triangle and flipping it over. So I'm going to flip it to the left, and so you would flip it like that and scoot it over here, and now it fits in right there. And so there's that triangle that fits like that. This is still a 30 degree angle right here. This is still a 60 degree angle. I'm going to erase these from over here. And so now I can fill out this coordinate at this point, and the angle and the radian. So I'm going to start from 0 all the way over to this angle that's at this point. And so I need to know what this entire angle is right here. So this angle is not just going to be 30. It's going to be measured from 0 all the way over here. So what I would do is take 180, subtract 30, and that would give me 150 for this angle. And if I change that to a radian, it would also give me 5 pi over 6. So notice that these two angles have the same denominator. So pi over 6 and 5 pi over 6. And now I'm just going to say this is negative square root of 3 over 2, comma, positive 1/2 still. I still went up. So I went over negative square root of 3 over 2, up 1/2. Now I'm going to take this exact same triangle, and to get the third quadrant, I'm just going to flip it down. Okay, so when I flip that triangle down and move it down here, it fits in right there. And so my 30 degree is still there. My 60 degree is still there. So now, my angle is going to be 180 plus 30 degrees. So this is going to end up being 210. And if I change that to a radian, that's going to end up giving me 7 pi over 6. And then the coordinate right here is going to be negative square root of 3 over 2 and negative 1/2. And then lastly, I can use this and flip it over to the right, so now it'll be over here and fit into this little piece. And so this is still my 30-degree angle, this is still my 60-degree angle. And so my angle right here, this is 360 degrees, but it'll be 30 less than that. So all the way around is 360, I want 30 less than that, so this is 330, and it would also be 11 pi over 6 when you convert it. And so then I would go over square root of 3 over 2, so x would be positive, and then I would go down negative 1/2. And so that would be my coordinate. And I'm going to go ahead and, excuse me, I'm going to go ahead and get rid of these since we're done with that triangle. And so now we've got those 4 angles filled in. I'm going to show you how to do a couple with the 45, 45, 90, and then I'll let you finish filling your unit circle in. So I'm going to group this, copy. Alright, so our 45, 45, 90 fits in like this. And so let's label this first angle that we get to in the first quadrant. So this is going to be my 45-degree angle. If I convert that, that'll be pi over 4. And then my coordinate is going to be the square root of 2 over 2, square root of 2 over 2. And so then I can do the exact same thing with this triangle that I did with the last one and flip it over this way, and it'll line up with that middle angle there. And so this is going to be, if I'm going from 0 all the way to this angle, it'd be 180 minus 45, which is just going to be 135. And then this is going to convert to 3 pi over 4. And so this coordinate is going to be negative square root of 2 over 2, square root of 2 over 2. And so then that's my angle there. And then I think you guys can fill in the rest of those angles by flipping it down and then flipping it over, converting your points. And so then I'm going to show you one more with this last one. And so you're going to use the same angle. I'm going to go ahead, that's 30, this is 60. You're going to use the same triangle. And this time you're just going to rotate it. So I'm going to show you how you would use this on your unit circle. So you take your 30, 60, 90, and you did use it like this, but now you're going to use it where it's turned up on its side like this. And in order to make it fit in my first quadrant, I'm going to have to flip it. Let's flip it again. I flipped it the wrong way. Alright, so I'm going to have to flip it like this, because now it will fit in right here. Alright, and so then my angle, this would be 60 degrees. This is going to convert to pi over 3, because this angle is 60 degrees. And this time I would go over 1/2 and up square root of 3 over 2. And so notice that these 2 points just switch. And so then you would flip it over to the second quadrant, fill in that angle, down, and then to the right again. And so that's how we're going to use our triangles to fill in our unit circle. And so you should stop and fill in the rest of your unit circle and get your completed unit circle. And in the next video, in part 2, I will show you what your entire unit circle should be. And so you need to make sure that you try to do this correctly, because it's really, really, really important that this is correct when you do problems involving the unit circle.